In this video, we're going to be talking about linear functions. Linear functions tend to give people a little bit of difficulty. This is graphing lines. So let's talk about a little bit of background first. The formula for a line has this general formula, and you've probably seen it before. Y equals mx plus b. Well, let's see if we can make this a little easier than maybe you've learned it before. There's the x. There's the y. Now remember, when you go to graph something, you go over, if you want to go to the spot 1, 2, and you're graphing, you go over 1 and up 2. This is the x and the y. Well, you'll see there's an x and a y in the formula. The only things that are sort of weird are these two things. What do those mean? Well, anytime you have a line, what's going to happen is that line is going to somehow hit the x-axis and the y-axis. It may only hit one of them, or it may hit both like this one did that I just drew in. So what this is called, this letter B, is called the y-intercept. Now the word intercept means to run into. So where does it run into? The y. And so that number that goes there tells you where it hits the y-axis. Now remember, this is the x and this is the y. The m is going to stand for the slope. Now this confuses some people sometimes, so let me give you an example. I like to go snow skiing, and whenever I go snow skiing, it's a lot more fun if I'm snow skiing, and I don't look anything like this, I don't think, but if I'm on my skis and I'm going down the slope, it's how steep it is. The steeper it is, the faster I'm going to go. There's my ski poles, and I'm ready to get after it, but I'm not a very good artist. But the slope is how fast it's going to be going. So every line is going to have some kind of slope, and then where does it run into the y? That's what those parts mean. Now let's see how we use a real example. Let's say we have y equals 2x plus 3. Well, there's some things we can know very quickly. If you look at the very end right here, 3 tells you where it runs into the y. So it's going to run into the y at positive 3, and positive 3 is right there. So it's going to run into that line right there. So I already know that my b is going to be the point 0, 3. Remember, b stands for y-intercept, so I know where it's going to hit. And then the slope is going to be 2. The slope is going to be 2. And what that means is how steep it's going. Well, if I were having to graph this, I have to figure out what the slope is from this point. And so here's what we do. 2 is also, the number 2 could also be written like this, 2 over 1. This and this are the same thing. Now you've probably heard it in your math class called rise over run, which means how far did you go up and then how far over did you go. So we're going to go up 2 and over 1. So if I go up 2 and over 1, that's what I get. If I go up 2 and over 1 again, I get another point. Well, if I can go up 2 and to the right 1, then I can go down 2 and to the left 1. Down 2 to the left 1. Down 2 to the left 1. You'll notice I have a lot of points. Just draw a line through there. Maybe you need a ruler. Draw my line through there, and there is my line. It has a slope. You notice it's pretty steep. It's pretty steep. Okay? So that's what it looks like. That's where it runs into the y, and that's how much slope it has. Let's try another one. What happens if we had one that looks like this? Y equals 1/2 x plus 3. We'll just make it look similar. Is it going to be the same graph? I don't think so. Slope's different. Let's start here. That's where it runs into the y. So at 0, 3, right there, that same place, 0, 3 is where it's going to run into it. Now, the slope is 1 over 2. Rise over run. So it's up 1 to the right 2. Up 1. Put my other lines in real quick. Up 1 over 2. Up 1. over 2. Down 1, left 2. Down 1, left 2. Well, that's what my general line looks like. Does that look the same? Is it as steep as the one a while ago? No, the one a while ago was really steep like that. So it looks a little bit different. It's drawn the same way. I know where it runs into the y-intercept. Okay, where it runs into the y-axis. Remember, this is x, this is y. Runs in at 0, 3, same place. But they weren't as steep as each other. So if I had a function like that, that's how I graph it. Okay? But what happens if I have the opposite? Let me draw a graph real quick. And let's say that I have something like this is a real typical question. Let's say we had something like this. And there's our line right through there. And they ask us, what does y equal? Well, I know it's going to be something x plus where it runs into the y. Well, I can figure that one out real quick. It runs into the y at 0, 3. So I know that's a 3. Now let's see how it changes. Okay, so I'm going to have the rise over the run. So how much up, how much right? Okay, how much up? And then I didn't go to the right, I went to the left. So I went up 1, left 1. So I went up 1, and I went in a negative direction. Did that happen again? Up 1, left 1, up 1, left 1. Yeah, it did. Is it down 1, right 1, down 1, right 1, down 1? Yeah. So I have a negative. Well, 1 over negative 1 is negative 1. So my formula is equal to y equals negative x plus 3. It runs into the y-intercept there, and it's a negative slope. Notice the other two I had a while ago went like this. That was a positive slope. This one goes like this, so it's a negative slope. Okay. Well, in the next video, you're going to see some pictures, and you've got to try to figure out from the picture what the formula is. Hint, always figure out where it runs into the y, and then count how much up and how much over to hit that line again and again. So in this case, I went up and left 1. So that was up, that was positive, and then negative 1, up 1 and negative 1. That's how I got it. Let's see how you do in the next section. Good luck.